All right, so in this first group, 1 through 5, it says solve each equation, no calculators. So what you need to be able to do is look and identify what type of equation we have. So in number 1, what is the name of this type of equation? Yeah, DP? Awesome. It's exponential. That's excellent. So when you solve an exponential equation, you isolate the exponential term. So we're going to add 5 to both sides, and I get 3 to the 4x plus 1 equals 27. Once you get the exponential alone, you need to pause and think. You have two possibilities. Either I can get a common base, and if I can get a common base, then I'm going to go from there. If I can't get a common base, then I'm going to go from exponential to logarithmic form. Okay? So, what do you think? Can I build a common base on both sides? Yes. Brendan, what would I rewrite 27 as? Well, that's 3 to what power? Yeah, 3 to the third, right? So then, now the bases are the same. I get 4x plus 1 equals 3. I'm not canceling the bases, okay? I'm not canceling the bases. But what I am saying is once my bases are the same, the exponents must be equal. All right, so subtracting 1 from both sides, x is 1/2. Now I want to pause a moment and make a beautiful connection from the equation to the graphs. What do you know about an exponential function in general? What does it look like? Can you give me arms without us standing up? Doesn't an exponential look like this? What do you know about the domain of an exponential then? Negative infinity to infinity. So I don't need to check my answer because the domain of all exponentials is negative infinity to infinity. Does that make sense? All right, so I'm going to keep making these connections. All right, number 2. What is the name of this type of equation? This is Captain Obvious here. Log. Okay, it's a log equation. So what you do is you get the log alone and then put it in exponential form. My log is alone. So I'm going to do 49 to the negative 1/2 power equals x. No calculators. I'm seeing some of you touching calculators. This says no calculator. Okay, no calculator on 1 through 5. So what do you do with a negative exponent? You make it a reciprocal, right? Yeah. So that's 1 over 49 to the 1/2. What's another way to say 1/2 power? Square root. Yay. Okay. Do you see how I'm doing one little thing at a time? Hey, what's the square root of 49? So, oh, okay. Do you see? We didn't need a calculator. Oh, now we got to pause a moment. In a logarithmic equation. Now, we didn't really practice this one with our arms, but you remember in a logarithm, the domain was 0 to infinity, right? So I do have to pause on logarithms and check them. So 1/7 is okay, right? That one's all right. All right, number 3. This is exponential. Let me pause. Can you get a common base? I think we can. So get a common base and solve that one. I'm going to give you a head start. The answer is a fraction. So I get 2 to the third to the x plus 2 equals 2 to the fourth. I multiply my exponents. The bases are the same. I get x equals negative 2/3. I want to stop and think. This is exponential. Exponentials are negative infinity to infinity, so I don't have to check answers. That's okay. All right, number 4. I have a logarithmic equation. It's alone. Look back at number 2. Again, do this without touching a calculator.
How is it negative 2/3? Because 6 minus 4 is negative 2.
4 minus 6. You subtract 6 from both sides? Oh, you forgot to multiply the exponents. It's 3x plus 6. Yeah, there you go. That's a good question.
You're good, bro. I'm not worried about that. That's crazy.
Otherwise, then you're right with what you had written down. That's what would have happened. Oh, I see some good answers. All right, the correct answer is x equals 6. I see several of you with that. Beautiful, beautiful work. Let's take a look. I get 4 to the 2 equals 3x minus 2. Well, 4 to the second is 16. Add 2. X is 6. Now, the inside of the logarithm has to be bigger than 0, so I have to check that. 3 times 6 minus 2 is positive, so it works. So I need to be careful that I could have actually gotten x was maybe say -1 or -1/2, and it could have worked, okay? All right, now, in number 5, this one's a logarithmic equation. On the left side, what's the problem? Why can't I set the two equal to each other right now? There's a problem. Yeah. Good job. On the left side, that log is not alone. There's a 1/2 in front. So, guess what I could do on this one? This is really some good thinking. I just caught myself before I started motoring along. What is log base 5 of 25? That's a number, right? That's 2. Okay? We need to have our thinking caps on. Log base 5 of 25 is the number 2. So I have 1/2 times 2 equals log base 5, 21 minus 4x. Then I can go from logarithmic form to exponential. So that's 5 to the 1 equals 21 minus 4x. I'll pause and let you finish it. Now, you could have brought the 1/2 up, and you could have done it the other way, and it would have still worked. 25 to the 1/2 is 5, and then notice you would have gotten to 5 equals 21 minus 4x. So sometimes there's more than one way to do these problems. Okay, sometimes there's more than one way, and that's okay. So I'm getting -16 equals -4x. I'm getting x equals 4. I have to go check it right here. 21 minus 4 times 4, that is positive, so that's okay. All right, questions on those 5? Anything that I can clarify for you? Exponentials. Get the exponential alone. See if you can get a common base. If not, go from exponential to logarithmic. Logarithms. Try and get the logarithm alone. Yeah.
For the logs, could you do 25 times 1/2? Like you know how you move it if it's an exponent to the front of the log? Could you set the inside of the log to the other inside?
So here's the thing, and let me make sure I'm hearing you clearly. If I have the 1/2 out front, I would have to bring the power up and then I could set 25 to the 1/2 power equals 21 minus 4x. Yes, I can do that. Good question. All right, 6 through 11. Now you can grab your calculators. And I'm going to give you 3 or 4 minutes, and I want you to try as many of these as you can on your own. These all require a calculator. So now that we've reviewed, see if you can do these. All right, just to make sure you're off to the right start. Number 6 is exponential. I cannot get the bases to be the same. So this is punch in the calculator, rounding 3 places. I got 0.772. Can you give me thumbs up? Did we get it? If you did not, raise your hand, let me help you, okay? In number 7, what does ln mean? Natural log, which means what? Log base e. Okay, anytime you see ln, that stands for natural log, which is log base e. Looks like most of you are past 7 as well. I got 4.389 for number 7. So check that one. No, that's not how you write it. Does yours not do, okay, yeah, that's not right. Let's see. If you go to math, there, you've got to go math and go log base. There you go. Yeah. Good question though, that we need to clarify that. All right, number 8. I'm going to do log base 4 of 3 equals x minus 2. And I got 2.792. All right, can you give me thumbs up? Are we getting them? Is it working? All right, good. And number 9, what's the problem? What's the problem in number 9?
It's not on its own.
It's not by itself. So what do you have to do first to get the exponential piece alone?
Divide by 10.
Divide both sides by 10. So I divide both sides by 10, and I get 5 to the 3x minus 3 equals 4. There's no way to get 5 and 4 to have the same base. So I do log base 5 of 4 equals 3x minus 3. I'm going to add 3 and divide by 3. And I got 1.287. All right, just because of time, I'm going to divide by 5 in number 10 and get e to the 2x equals 12. Then that's log base e of 12 equals 2x, which is natural log. Dividing by 2, you should get 1.242. Again, today we are just revisiting all the different equation solvings, just so that now they're just being thrown at you. What do you do? Any questions? Anything else before we do the last one? All right, number 11. I have log base 2 of x plus 2 minus log base 2x minus 5 equals 1. All right, on the left side, something should be jumping out at you that we should be doing. Does anybody see it? Condense. Ooh, and I love the mathematical language. So if I'm going to condense, that's x plus 2 divided by x minus 5 inside the log. Oh, and this was on our quiz, remember? So I'm going to go from logarithmic to exponential form. So we condensed it down to 1 log. Well, 2 to the first is 2. And then make that 2 over 1. Anytime you have one fraction equals one fraction, that's called a proportion. Again, when you have one fraction equals one fraction, that's a proportion. How can you solve a proportion? Anybody remember? Yeah, Nick. Good job, cross multiply. So I get 2 times x minus 5 equals 1 times x plus 2. I get x equals 12. This is a log. I have to check my logs. 12 plus 2 is positive. 12 minus 5 is positive.